Hello everyone, my name is Helen Zheng. I'm a senior lecturer in spatial planning. Today I'm going to quickly show you how I use the GeoAI to study place-based inequalities. So why digital? Place-based inequalities operate across different spatial scales. For example, in Greater Manchester, from local to local authority to neighborhood and even to the street level. And the micro environmental characteristics are difficult to be captured in traditional data sets. And the GeoAI provides the opportunity to extend spatial analysis to help us understand the environmental features that are highly dimensional and complex. And addressing place-based inequalities require interdisciplinary efforts, and we can bring across all the evidence in space and try to understand the environment and also translate the evidence into policy and practice. So here I'm going to show you an example. I used GeoAI to understand the obsogenic environment by using street view images. We collected over 120,000 Google Street images from Greater Manchester across these different streets. And then we used deep learning methods to extract the objective and subjective features of the environment. And we also use spatial analysis and machine learning methods to establish the relationship between these environmental features with obesity prevalence. So here you can see just some spatial variations of obesity prevalence across different local authority, local areas in Greater Manchester. And the right one shows the hotspots of the prevalence of obesity. The red color represents the areas with high obesity level, surrounded also by high obesity prevalence. And we know that sociodemographic factors and also behavioral factors are also important. So we overlay the prevalence of obesity with, for example, IMD index of multiple deprivation. We find a high correlation between these two factors. Similarly, we can also see the high correlation between obesity prevalence and also commuting behavior, percentage of commuting by car. So now I'm going to explain how we used a street view imagery to capture the objective objective features and the subjective features of the environment. Firstly, we used deep learning methods to extract the subjective features, for example, like vegetation and sidewalk. And we can see the upper figure shows the street with vegetations and wide sidewalk, and the lower one shows the area of the street without vegetation and with narrow sidewalk. We also used deep learning to extract perceived features based on human perception database, and we can see the perceived scores of safety and beauty for different types of streets. We also used the machine learning methods to capture the nonlinear relationship between different objective features and obesity prevalence, and these features cannot be easily captured by traditional statistical methods. Similarly, we also observed nonlinear relationships between safety and obesity, beauty and obesity, and along with other social and behavioral factors. So in summary, GeoAI enables new way for us to understand the environment that is very complex. And as a spatial planner, we try to integrate all the evidence across different disciplines and try to understand the environment in a more comprehensive way. And we need to use this spatial evidence, and this evidence can support decisions across different domains. Not only in this example, also in other examples, for example, transport, energy, and even climate change. So that's all for my presentation. Because I need to teach, I cannot stay. And if you have any question, feel free to email me at helen.zheng@manchester.ac.uk. Thank you very much.